You mentioned
Yes.
Data
you mentioned
transfer.
that data cleaning and outliers that you treat it separately.
Okay, I think we are done with the transformation, right?
Yes, that's where we
Yes, that's where we are.
did
Good,
last.
good, good. So now it's high time to start with the data like clustering, right? So main machine learning component are clustering and classifications, right? So once we are done with clustering, then we'll start with classification and some more important issues like overfitting, underfitting, and good fitting. All these components are still left. So we'll talk about them one by one together with clustering and classification, right? So, dear
Yes.
class, so I don't know if you have little bit idea of the clustering. I'm not sharing anything. I will share. Don't think that I'm just like mentioning the clusters, right? Clusters means grouping the similar item together. Clusters, like you see, grouping the similar item with similar characteristics, right? So if just like see, if you go to shopping mall, you will see that items in the shopping mall are always clustered in a group. How they are clustered in a group? Like if you go to the area, you will see that vegetable area is together. You cannot find in a shopping mall vegetable together with cloth. No, 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 because they are always keeping the item in the clustered group, right? I've seen in the arrangement in good shopping mall, even in your house, you can't keep a kitchen thing with other things, book. You cannot keep a book in your kitchen. Am I right?
Yes, yes, sir.
So how this is happening? Is it not a cluster that reading material, books are in separate place, one place, your kitchen thing is separate, cloth is separate, all these things they are grouped together. Because if you go to any places like see potato, so it may be two potato category, Irish potato or sweet potato. And if you notice it clearly, you will see that both of them they are placed together in any shopping mall. So what is this concept class? This is the concept of clustering, grouping the items with similar need, similar. So this similarity measure, how to measure the similarity, right? That how you think that two items are like say, similar. So that the notion of the similarity, right? Yeah, that is the notion of the similarity. Let me just explain you how to understand this similarity in major sense, right? I'm coming. So similarity and dissimilarity, two concepts are going to be used in the like machine learning. Two concept, right? One is similarity. I'm talking about similarity. Yeah, is similarity, and other is dissimilarity. Yeah. So first task is similarity and second task is dissimilarity. Similarity means how two items are similar. Dissimilarity how they are not similar, how far, right? So dissimilarity if they are equally equal, so dissimilarity will be 0, right? Yeah, and similarity will be 1. Are you getting my point? Suppose if I'm talking about like this item, suppose I'm talking about dog and another item is also dog. So what is similarity between them, class? How much what is similarity between this dog and this dog? Is it not like both are similar?
They are
Yeah,
similar.
similar.
So can't we say that similarity, let's say if I'm talking about similarity between dog and dog is one, it can't we say like this?
Yes, it's true, sir.
We
Yes,
can
And
sir.
say that.
what of this similarity between dog and Dog, are they dissimilar? How much is the dissimilarity?
0.
0. So that means both are like opposite metric, right? Both are opposite metric. So this is one thing. What is similarity between, if I'm talking about similarity between 2 and 2.0, is it not 1?
It's 1.
Yeah.
One.
And what is similarity between 2 and 4?
Is 2.
2. Right. How to know 2? Because you subtracted 4 minus 2, right?
Yes.
Good. So you know this thing, and we are going to understand. So what clustering will require? Clustering will always require that how to group the item together. Let me ask one more public opinion. Huh? Public opinion is very, very important to understand something. Very, very important. Suppose class you have point in 2 dimension, right? Suppose you have point in 2 dimension. Point or any keyword, any document you can take in 2 dimension. 1, 2, 3, and 4. Suppose one point is here, right? Another point is here, and another point is here, and another point is here. My question is that suppose you are being given 3 clusters. So can we say the cluster number 1, cluster number 2, cluster number 3? We are given 2 clusters. I want to know the cluster numbers. How many clusters you have been given? Class 2, right? So can you tell me how to place them? Hey class, can't we say that this will be going to one cluster? Is it correct?
Yes.
Yes,
Can't
sir.
we say that this guy is going to join in another cluster?
Yes.
Can't
Yes, sir.
we say that this is join another cluster?
That means 3 clusters.
3 cluster. So that means and the objective of the clustering is always that intra-cluster distance, right? Intra-cluster means within cluster. Intra-cluster distance is always minimum, and inter-cluster distance is always going to be maximum. So this inter-cluster distance is always going to maximum, and intra-cluster distance should be minimum. That is the objective of the clustering. If you just understand very well, these are 3 clusters. So suppose class I have only 2 cluster. What will happen? Suppose you have only 2 cluster. So this point may go with this, and what will happen? This point, there is a problem. Only 2 clusters are given. Only 2 clusters. So conflict will be that these 4 points may be joining one cluster, or this will be joining one cluster. So depending on who is closer and why, right, to whom. Is it clear? You are given only 2 cluster, right? So it was 3 cluster when you separated, but it is also possible that you are given only 2 cluster. So these point may merge with these point, or these point may merge with this point. It depends on the situation, or this point can go with this, and this point can go with this. So many situations are possible, right?
Yes.
Yes, sir.
So this is the objective of the class. Now question is coming, how to calculate the distances, and how to compute the similarity matrix, and how to compute the similarity between 2 objects. Before coming to the clustering, you need to know the similarity matrix, dissimilarity matrix, and similarity distance calculation. 3 things are very, very important. Otherwise, you may not be able to calculate the similarity. Okay, before going to the similarity measures, right, let me just define something, then I will explain that similarity measure in detail, right? So you should know the chapter background, why we need it actually, why we need similarity measure. Class, suppose you have point in one dimension, 2, 1, 6, and let's say 3 and 8 and 5. Suppose these are the point in one dimension. So if I'm saying that like see, suppose, and you are given only two cluster 1 and cluster 2. Two clusters are given, right? Yeah. So you are given only 6 point. Question is that how to find out only two cluster. Those who are intelligent, they can easily say that 2 and 3 will join one cluster, 6, 8, 5 will join another cluster, right? Yeah. So R, yeah, somebody can say that, okay, suppose I'm saying 13. So somebody can say, okay, 2, 1, 6, 5 will join another one cluster. 13 and 8 may join another cluster. So many speculations are coming, right? Right, class?
Yes, sir. Yes,
So
sir.
you know the distance between 2 points, right? It's very easy. How close these 2 and 1 are? 2 minus 1, 1. 2 minus 6 is 4. 2 minus 13 is 11. So these are the closeness of the distance. So how our important algorithm, you will see that K means will be the one first algorithm in this category to come. K means, K is a parameter. K means two clusters, right? So if you are talking about two cluster, it will be two means, right? Yeah. If you are talking about three cluster, it will be three means. Is it clear, class?
Yes, sir.
Means is your average. Okay, so suppose me and this is like representative. I'm not starting K mean directly now. I will give you the background, then we'll go back to distance calculation and then come back to the K means and introduce it formally. Let me just explain you why it is needed. Okay, so suppose class, this is your cluster number 1. This is representing cluster number 1, and suppose this is representing cluster number 2. Suppose this is the one. So let me say like this. Let me say like this. Cluster number 1 and this is cluster number 2. Cluster number 1 is 2 and cluster number 2 is 1. Right? Suppose this is the situation. Cluster number 1 is 2 and cluster number 2 is 1. Clear? Clear, class?
Yes,
Yes, sir.
Good. So now, if you just start with these clusters, okay, so can we say like this is the point, yeah, like see 2, 1, 6, 3. You will understand the clustering meaning, 8 and 5. These are the point. Suppose I am talking about this column, distance from cluster number 1, and this is distance from cluster number 2. You will understand this meaning actually. Cluster number 2. What is cluster number 1? Cluster number 1 is this 2, and what is cluster number 2 is 1. I hope it is clear, right? Yeah. So what is distance of this 2 point with cluster number 1? Cluster number 1 itself is 2. Distance of 2 and 2 is 0. Distance of C2, 1 with 2 is 1. Take it positive distance. Take the modulus. Distance of 1 and 2. Right? Yeah. Come here. Distance of cluster 1 with this point, right? 1. So this is 1. Distance of this point with cluster number 2 is 0. 1 and 1. Come here. Distance with cluster number 1. Cluster number 1 is 2. 6 minus 2 is 4. Right? And distance with cluster number 1, 2 is 1. So 6 minus 1 is 5. Very simple. Right, class? And this is 13. if you go here, distance of 13 with 2 is 11, right? And then distance of C2 is 1, and 1 and 13 is 12. This is one of the problem. 8 minus 2 is 6, and then 8 minus 1 is 7. 5 minus 2 is 3, 5 minus 1 is 4. This is the distance calculation, right? And calculate the minimum value. This is the 0 and 1, minimum is C1. So this point is going to join C1. And this is minimum is C2, this is going to join C2. This minimum is C1, this is going to join C1. This is again C1, this is going to join C1. This is again C1, this is going to join C1. This is again C1, minimum, this is going to join C1. Clear, class?
Yes, it's clear, but please, could you explain again from the first
I'm
0
coming.
and 1?
Okay, I'm coming. Okay, you know, you have point 2, 1, 6, 13, 8 and 5. These are the one-dimensional point, right?
Yes.
Question is that, you know, you can take any, and problem is that you have been given only 2 cluster, and question is that how to divide these 2 points in 2 clusters only. Assume that cluster number 1 is being represented by 2 and cluster number 2 is being represented by 1, right? Yeah, this is the situation.
Yes.
So now this is the column which is representing distance with cluster number 1, and this is the point where it is representing distance with cluster number 2. Clear?
Clear.
Now your cluster number 1 is 2 and cluster number 2 is 1. So distance of 2 with 2 is 0. Distance of 2 with 1 is 1. Same thing here. Distance of 1 with 2 is 1. Distance of 1 and 1 is 0. Clear?
Very clear.
Yes, sir.
6 minus distance of 6 and 2 is 4. 6 distance of
Very
6
clear.
and 1 is 5. Clear?
Very clear.
Yes, sir.
13 minus 2 is 11. You know, you have to take distance as modulus. Don't take as like non-modulus. Don't take sign. So 13 minus like 1 is 12. Clear?
Yes, sir.
8 minus 2 is 6. 8 minus 1 is 7. 5 minus 2 is 3. 5 minus 1 is 4. So you need to just calculate the minimum between them. So this is the minimum distance C1. It will go, that means this 2 point will go to C1. Same thing here is C2. This is the minimum 0. It is going to C2. And this is going to be joining C1. This is going to join C1 again. Anyone is minimum, right? C1 and then C1. I hope it is clear to everybody now. Is it not
Yes,
clear?
sir.
It's clear, sir.
Okay, good. Now, question is not this. Question is something else. So class, after this iteration, after let's say, suppose you are using first iteration, what is happening? You know, only how many points are in cluster 1 and how many points are in cluster 2. Let me know. How many are point? Like 2, right? And then 6, clear? And 13. I hope you understand it, right? Yeah, all cluster number 1. This is the cluster number 1. 2, 6, 13, 8 and 5. Clear?
Yes, sir.
Who is in cluster number 2? Number 1 only. This is the division after pass 1. Noted? Class, are you done? Hello?
Yes, sir.
Yes, sir.
Hello, Doc. I said, could you explain again the grouping that you are doing now?
No, you are writing C1, C2. How you are writing? Anyone minimum is minimum, that will go to that group. So 0 and 1. Which one is minimum? 0. It will go to C1. That is it. 1 and 0. This is minimum is C2. It will go to C2. 4 and 5. Minimum is 4. So it will go to C1. 11, 12. Minimum is C1. It will go to C1. 6, 7, it will go to C1. 3, 4, it will go to C1. Any number of cluster like C1, 2, 6, 13, 8, 5. All of them, they are going to cluster 1.
Correct.
This guy is cluster 2, right?
Yes, sir.
So where is the
Understood.
Where is the problem? No problem, right? Yeah. So class, can you take the mean of this? Take the mean of this. I want you to take average of this, take average of this. So since C2 is having only 1 point, its average remain 1. And what is average of this? Two plus 6 plus 13 plus 8 plus 5. 34 divided by how many point class 5? 6.8.
6.8.
Yes. So now this guy is cluster number 1 and this guy is cluster number 2. Clear?
Yes, sir.
So I hope you have noted it.
Yes.
Okay. Class, this space I want to utilize if you don't mind.
So, Prof, I want to ask a question. Based on what we have done so far now, what have we achieved from this explanation now? Based on these 2 points now, we have point C1, 6.8, and we have cluster 2 and 1. The first cluster is 6.8, and the second cluster is 1. When you find
what we are trying to achieve, we have not achieved anything. We are trying to divide these points into 2 groups, right?
Okay, sir.
So right now we don't know this group is correct or not. We don't know this grouping is correct or not, right?
Okay, sir.
So what you should do, after initially you decided that let this 2 represent cluster 1, let this one represent cluster 2. Let's see, 2 is Oga of cluster 1, 1 is Oga of cluster 2, right? Initially, you can take any point as cluster 1, any point as cluster 2, any point as representative of cluster 1, and any point as representative of cluster 2. Clear?
Yes, sir.
Yes, sir.
So now, after taking this, you have to take the mean. Its name is very popular algorithm, K-means. I will explain it in detail. Once you take now, your 2 is no more representative. Who is representative of cluster number 1? 6.8. Clear?
Yes.
Yes, sir.
So now, what will happen? Your pointer is still the same. 2, 1, 6, 13, 8, and 5. Right? Yeah. And now,
Yes,
distance from cluster 1. This is the 1. And now, this is distance from cluster 2. Clear? Yeah. And if you could remember, cluster 1 is 6.8. And this guy is 0.1. So can you, you remember cluster 1 is now 6.8, cluster 2 is now 1. So can you differentiate what is distance up to with 6.8? 4.8, right?
4.8, yes.
And this is distance up to with 1 is 1. Clear?
Yes.
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 So this is 5.8 and this is 0. This is 0.8 and this is 5, if I'm not wrong, right? Yeah. This
Correct.
is like 13 minus 6, 6.2. Yeah. And this is 12.
12.
So
8, this is 1.2. And this is 7. 5, this is 1.8. This is 4. So now let us divide into the cluster. This is cluster number 2. This is the minimum, right? This is cluster number 2. This is cluster number 1. This is cluster number 1. This is cluster number
Cluster number
1.
one.
This.
Cluster number 1.
Yes. Clear, class?
Yes.
Yes.
Yeah. So now you see here, this is your cluster 1 and this is your cluster 2. Yeah. So this cluster 2 is 2 comma 1 and this is 6 comma 13 and then 8 and 5, right? Clear, class?
Yes, sir.
So what is mean of this 2 plus 1? Its mean is now 1.5. What is its mean? 13 plus 6, 19 plus 5, 24 plus 8, 32 by 4 is 8, right?
yes,
Class.
8.
Yes, sir.
8 is the average, yes.
8 plus 5, yeah, it's like, no. 30, yeah, it's 32 divided by 4, no? 4 point is 8. So now, again it will go to the third iteration. I am writing here, I know that you can write it clearly, right? Yes. So this is 2, this is 1, this is 6, this is 8, this is 5. Yeah. And this is distance between cluster 1. Cluster 1 is 8. And this guy is distance between cluster 2. What is cluster 2?
1.5.
Is 1.5. Yes. So if you could divide it, so 8 minus 2 is 6 and 1.5 is 0.5. That means this is the one. 1 minus 8 is 7 and this is 0.5. Good. 6 minus 8 is 2 and this is like 4.5. 13 minus 8 is 5 and this is like 11.5. Yeah. 8 minus 8 is 0 and 8 minus 1 is 6.5. Yeah. 5 minus 8 is 3 and 5 minus 8 is 3.5. Still this guy is C2, this guy is C2. All of them they are C1. So no change in the cluster, right class? Hello?
Hello, sir.
Yes.
There is no change in the cluster. There is, these points are not migrating. Am I right?
Right.
Yes, sir.
C1 is still remaining the same. C1 and C2. What are the C1? 6,
6, 7,
13,
13.
8 and 5. Yeah. And then 1 and 2. Yes. So this is C1 and this is C2. Clear?
Mhm.
So that
Sure.
means this cluster remain the same since there is no change in the cluster. So you will take the mean, point will remain the same. So after this deliberation, you have seen that any number of cluster at the beginning, any point you are choosing, they will adjust according to the minimum distance parameter. Clear, class?
Come
Yeah.
again, sir.
Me,
Come
I'm
again, sir.
saying that any cluster you are choosing at the beginning, it doesn't matter. Point will adjust according to their distance, right?
Okay, sir.
You
Yes,
see,
sir.
even if you are taking any, let's say cluster 1, you are taking 2. Cluster 2, you are taking 13. It's not a problem. It will still give you the same result. Right?
Okay.
Point, yeah.
Okay, sir.
Number of iteration may be different, but you will get the same result. Result is not going to be changed. So final result of the cluster will remain the same. So class, this was one dimension. So how you calculated the distance is just like difference between 2 points, right?
Yes, sir.
But what will happen if you have multiple columns, not one column, two column? What will happen if you have 100 columns, 100 multiple dimensions? You have only one columns, like one dimension point. So calculation of distance was not difficult. But if you have multiple point, then what will happen?
It will take a longer time to achieve this.
Not longer time. We have to go for some distance calculation measure. So let's talk about, my objective is to just introduce the distance, right? So how close 2 points are, how to calculate the distance. This procedure, I will explain it again. For 2 dimension, 3 dimension, we can explain for the document also, like document, just like you have seen dog, if they are same it will give you 0. So this kind of distance calculation for document is different, for binary number is different, for like the continuous number is different. If I'm asking, let me ask one question from you. Suppose I'm asking a question from you, right class? One point is 101 and another point is 010. Can you tell me the distance between them? Class, can you tell me the distance between these 2 points? One is x and other is y. Me, I'm asking what is distance between these 2 points? Ah, let me ask Dr. Rose. Dr. Rose seems to be like silent. Why?
I'm on transit, sir.
You are traveling?
No, I went out, just returning back home. I've been trying to follow, but I've not concentrated so well.
What of Lucy?
I went somewhere.
Lucy,
No, I'm around. I'm following, sir.
Lucy, what is distance between these two vectors? They are binary vector, right? They are written in 1010 something. So what is distance between them? Try. How
So we
close
have
these 2 points are?
Yes, the distance will still be done by binary calculation. That's what I'm looking at.
Yes, so how close they are? What is distance?
Little time to check.
Check now. Nonso, are you there? I hope you are
Yes,
not on
yes,
transit.
I'm trying to check it also, sir.
I hope you are not on transit.
No, sir, no, sir.
You have
but
7
this is how
students, only 5 are there in the class, right?
Mr. Ape joined, but I will talk to him later. But right now we are complete, sir.
Oh, you are only 6?
5 plus, yes, only 6, including Mr. Ape.
Okay. So what is distance between these two vectors? Can you conclude little bit? Can you see and let me know? Aliyu,
Yes, sir.
try now. It's very
I'm also
simple
working on
question.
it, sir.
Huh?
Yes, sir.
How close they are? What is distance between them?
So I'm still working on it, sir.
So this is not 2 dimension.
It's not 2 dimension, it's a vector.
Okay.
What is his name? I can't read. Callistus. IK. IK, can you hear me?
I'm here. I'm working on it.
Can I say you IK? Can we call you IK? You are muted. You are muted.
I say IK is different. I can be a Carl. Maybe I will change the name in the next class.
Oh, you are not IK?
No,
Then,
Carl is better. Or Callistus.
Callistus is your better, huh?
Yes, sir.
But your name is Iku Ajum Callistus. So that's why I'm taking beginning 2 name, 2 character.
Okay, next class I will make it short.
Okay. Ogali, you, how far?
Yes.
It's very simple, it is 1 minute 30-second task.
Yes, just a little time. I'm on
Okay,
it.
okay, let me help you out. Huh? Okay, look at here, class. 1 and 0. Are they similar? No? Class.
They are not similar.
So how that means their distance, what is distance between them? 1 minus 0 become 1, right?
Yes,
Yes.
sir.
Yeah.
1 plus. Let's add them now. What is distance between them? Is it not 1?
It's
1.
one.
What is
1.
distance between them?
1.
One.
What is
1,
distance
1, 1.
between them?
One.
1. Is it not 5? Class.
It's 5.
Yes, sir.
So that means these 2 vectors, they have 5 length and they are entirely different. Look at here, it's very, very simple. Their length is 5 and they are and if their distance is also 5, that means they are entirely different. On the other hand, if I'm talking about this and y is 0, 1, 1, 0, 1, what is distance between x and y now? 1, first vector they are different, second is different, third
No,
is
zero.
remain the same, fourth remain the same, and
Zero.
fifth.
Yes.
Is it not 2?
Yes.
That means they are different in only 2 places. Am I right?
Yes, sir.
Yes, sir.
And while they are entirely different because its length is 5 and if their distance is also 5, that means they are differing in all the positions. Here their distance length is 5, but their distance is 2, means they are differing in only 2 positions. So if you are somebody saying that, okay, which distance is close? Tell me, this x is close to this y or this x is close to this y? This y, right?
Yes,
Yes.
sir. The second one.
Second one is so simple. So there is no need to worry about this. Is a very basic calculation. But these vectors, right? So their own calculation is different. You are just checking the differences. They are difference 1, they are differences 1, they are same. So this number of bits they are differing, right? Number of bits they are differing is the distance between them. Clear?
Yes, ma'am.
Yes, sir.
Yeah.
So my point is that, you are not subtracting here. If you are subtracting, it will give you different answer. If you cannot subtract this value with this value. So vectors, binary vector have different distance calculation. Number, they have different distance calculation. Document will be having different. Okay, let me ask one thing. I will also explain something. I don't know if you are aware with ASCII value. Are you aware, class?
Yes.
Wow, you know it, right?
Yes.
Yes,
What is
sir.
ASCII value of this?
Is 1. 0, 0.
No, its value is 65.
Okay. Okay.
Okay, let me come. Maybe those, all of you are may not be aware. This is ASCII, ASCII. Its
Yes,
full
I
form is
understand.
American, right?
Yes, sir.
Standard code interchange.
Standard
Code
Code
interchange.
code for information
Information interchange.
interchange. And it's a 256 like character code, 256 character code, right?
Yes, sir.
Are you getting my point? This
That's
is
correct.
every computer scientist should know it, right? So 256 means 2 to the power 8. Class, am I right or not? 2 to the
Yes, sir.
power 8. You should know it. Even if you don't know, you should know now. This is 2 to the power 8. Character code. And that means in order to represent all these 256, you need 8 bit of the value. You need 8 bit to represent all 256 character. Maximum is 256 character. Maximum in keyboard is 256. You cannot get more than 256. Whatever you can see in your word, and all of them, they are 256. And each character, right, class? Each character has a decimal equivalent. Each character is having decimal equivalent. So if you write capital A, its decimal equivalent is 65.
65.
Capital B is 66. This is the decimal. It is standard. Nobody has defined. It is American standard. So they decided that, okay, let's treat capital as a number, because whatever you are typing as character is stored as a number, right? Yeah. And
Yeah.
in this category, A will be small a. Can you tell me? 90.
96 or 7. Yeah.
B is 98. Just increase one by one, right?
Yes.
In this category class, 0 is treated as how much? 48. Clear?
That's it.
0 is not 0, 1 is 49. There are some more characters also. All 256. Actually, this 256 is 0 to 255. All this, they will be treated. Number will be 0 to 255. So now, after reaching this thing, if I'm asking what is distance, suppose x is like dog and y is dog. What is distance between x and y? Anybody who is very intelligent will tell me. Note down the question and calculate the distance between the capital dog and the small dog. Note down the question and then I will go with this. Capital D. How much is capital D, class? How much is capital D?
is
A
90,
is 65, 66, 67. Is it not 68?
68.
Hello, class.
Yes.
And how much is small d?
Small d is 97, 97, 98, 99, 100. 99, yeah.
A is 97, B is 98, C is
99, 100.
99, D is 100. Rest are okay, right? Rest OG remain the same. So if somebody is saying, can't we say that they are differing in only one position? So 100 minus 68 is how much?
32.
32.
So is it not like a very good thing that, this is a number, their own distance calculation is entirely different from other, right?
It is.
This can differ. And that's why you see both are different. Had it been, it is also D small, it is also D small. So you know what, 100 minus 100 could have been 0, right class? Hello?
Yes. Yes.
Yes,
So I
sir.
hope you understand the objective of the lecture, right?
Yes.
Yes, sir.
Okay, good, very good. So let's understand this various distance measure, where in this various distance measure, you will be talking about one-dimensional point, two-dimensional point, three-dimensional, in fact, multi-dimensional. We will be talking about document, we will be talking about binary vector. So these different distance measures you are going to calculate. And what is essence of distance measure, why we need these distance measure, so that we can check whether how they are going to form the cluster, right? Basically distance measurement is used in clustering the items, nothing else. Are you getting my point?
Yes.
Yes,
Yes,
sir.
sir.
Remember class, this distance measure is not going to be used in classification. This distance measure is only going to be used in clustering. Clear?
Yes, sir.
Yes, sir.
Can I go ahead?
Yes,
Yes,
sir.
sir.
So similarity and dissimilarity. So similarity means numerical measure of how alike two data objects are. How similar? You know it already. Is higher when objects are more alike. Often falls in the range 0, 1. Maximum means if both are same, it will be 1. If they are not same, it will be 0. So this is the similarity count between 0 to 1. This similarity on the other hand is different thing, right? Yeah. Numerical measure of how different are two data objects. Lower when objects are more alike. Minimum dissimilarity is 0, right? Yeah, and upper limit varies. So, number one, distance calculation. Those who are done with mathematics, they know Euclidean distance, right? Class, do you know Euclidean distance?
Yes, sir.
Yeah.
No,
So
sir.
what is Euclidean distance between any 2 points? Pk minus qk whole square and sum over k from 1 to n, where n is the number of dimensions. Attributes pk, qk are respectively the kth component or data objects p and q. Note down this formula, class. Hello.
Yes, we are taking notes. Let me on to screenshot.
Note down. Don't take a screenshot. I will give you the time.
Okay. Distance equal to yeah, done.
Please wait.
Class, suppose you have 2 points, right? Like say 1 and 2. 1 point is 3, 4. If somebody is saying what is distance Euclidean between them, can you tell me? It is 2 dimension and you know it already. 1 minus 3 square, right? Plus 2 minus 4 square. Clear?
Yes, sir.
Hello class.
Yes, we are following.
Yes. 1 minus 3 square plus 2 minus 4 square. This is how distance between them is calculated. It is 2 dimensions, so it is 4 plus 4. It is 8. This is exactly the distance between these 2 points, right?
So this is for 2-dimensional.
Yes.
Okay.
You know point-wise point. 1 minus 3 square plus 2 minus 4 square, right?
Yes, sir.
Yes,
Okay.
sir. Where did you get 4 from? Sorry, sir.
Huh?
The 4 is from where?
1 minus 3. 1 minus 3 squared is 2 squared, which is 4.
And then then we have 2 minus 4. Where is the 2 minus 4 coming from?
This is 2 minus 4 now. Point-wise point subtraction. Look at here.
Okay,
pk
2
minus
minus
qk.
4.
1 minus 3 square plus 2 minus 4 square.
Is 4. Yes, it's correct.
I don't
You know
understand.
it is point-wise point differences, right? Lucy, is it clear?
Okay, is it 1 and 2 and then 3 and 4? It's not clear to me.
Oh God, these are the 2 points. Like, see, if this, suppose this is your 1 point, 1 comma 2, right? And let's say, and this is another point, let's say 3 comma 4. Somebody is saying that what is distance between them? Tell me. So how to calculate Euclidean distance between these 2 points?
Okay, okay. I didn't see the 4. It's okay. I wrote the 4 as another number. Okay. I understood now. I
You know,
understood.
I'm writing PowerPoint. You know, this is not easy for me teaching online.
For me, I've gotten you, sir. I've understood, sir.
Okay. So can you tell me, can you just do me one favor that suppose this is your point in 2 dimension, 2, 1, 3, 5. Let's say this is 4 dimension. And another point is also given. You know, data, this machine learning is always dealing with multiple dimension. It's not like dealing with only one dimension. Can you calculate distance between P1 and P2? Try now.
Do we apply the same Euclidean?
Yes, same
Yes.
Euclidean. Euclidean is same Euclidean. It's very, very fundamental.
Well, in P1, after 2, what is it 3 or what?
This P1, 2135.
Okay, 2.
2135.
2135. And 4216, right?
2135 4216.
Square root of 10.
Square root of 10.
Yes, sir.
Yes.
Yes, square root of 10.
Very correct. Very correct. So there is no problem, right?
Yes, sir.
So I hope you understand this distance calculation, Euclidean especially. So it's very very simple. It can be multi-dimension, it can be it can be two-dimension, or even it can be one dimension also, because if it is only one dimension, 4 minus 2 square is, and take its square root, it still will be 2, right? So this is very
Yes, sir.
generic formula for any number of dimensions. Okay, class, this is the most important part. Suppose you have 4 points given like this. P1 is x point, y point, all these points they are given to you. Me, can you write this point? Just write this, don't write this matrix. This distance matrix I will let you know separately. Can you just write this point? Number 1. This matrix, class, write down each point and this point, matrix.
P3 to P4, right?
No, you are not getting my point. Write down this.
X and Y, point to X and Y.
Yes, I know. Okay.
XY means P1 is 0, 2, right?
Yes.
P2 is 2, 2, 0.
3,
P3
1,
is 3, 1.
5, 1.
And P4 is 5, 1. This is the point which are given.
Yes, sir.
Taking.
Please note down this. I want to teach you separately. How many points you are given? Class 4, right?
4
4
points.
points.
So this matrix I want to redraw. Let me.
Okay.
Yeah, this is not giving me space to write. I want to get space to write, so that at least you should be happy.
Thank you.
Yeah. Class, what you should do, this is the matrix, right? Yeah. Write down, leave the P1 first, P2, P3 and P4. Yeah. And here is P1, P2, P3. I don't know if you you can correlate or not. Because distance between P1 and P1 is always 0, right? Hello.
Yes, sir.
Distance between P1 and P1 is always 0. So P2 is 0, P3 is 0. So if you are given 4 point, leave the first point, P is to write P2, P3, P4. And if you are given here, write down P1, P2, P3, right? So now P1, P2, distance between P1 and P2. Can you calculate distance between P1 and P2? This P1 and P2. This P1 and P2 distance is 0 minus 2 square
Okay.
plus 2 minus 0 square. So this is 4 plus 4 root number 8. And root number 8 is 2.828. Clear? Class, clear?
Yes, sir.
Distance between P1, P3, 3 square 9 plus 1 10. Root 10 is 3.16. Distance between P1 and P4, 25 plus 1 26. This is 5.09. Note down this. P1, P2, distance between P1, P2, 0 minus 2 square plus 2 minus 0 is 4 plus 4, 8. And root of 8 is 2.828. P1, P3 is 0 minus 3, 9 plus 2 minus 1, 10, 3.16. P1, P4 is 0 minus 5, 25 plus 2 minus 1, 1, 26 is 5.099. Clear?
Yes, sir.
Yes, sir.
P2, P2 is 0. No distance between P2, P2. P2, P3. P2, P3. 1 plus 1, 1.414.
Mm-hmm.
P2, P4. P2, P4 like 9 plus 1, 10.
3.162.
This is, we are not interested in writing here because P3, P2 is same as
It's
P2,
zero.
P3. No. Distance between P3, P2 is same as P2, P3. So we have already written it, right? And distance between P3, P3 is 0. So no need to write here. Clear?
Okay.
Yes, sir.
Look at here. This value P2, this is P3, P2. Is it not P2, P3? It's the same. This is P3, P2 is same as P2, P3. So
Yes.
P3, P4 is like 4. Yeah, it is 2.
Three, two,
Clear, class?
square, four, right. Okay.
Is it clear?
Yes, sir.
Yes, sir.
This we don't want to be repeating. Actually, repeating is not good thing. So this is a very good matrix, symmetric in nature. Look at it, is like upper triangular matrix. This is upper triangular matrix. Clear?
Yes, sir.
This is Euclidean distance, but matrix between too many points. Like how to calculate the Euclidean distance between the point. You can do this way. You can follow this formula.
I want to ask a question.
Yes.
Okay, in the one that you have on this chart
Mm-hmm.
on the screen and the one that you have used pen to write,
Mm-hmm.
you started with P1, P2, P3 on the y-axis, and on the x-axis you have P2, P3, P4.
Mm-hmm.
Now on the screen you have P1 to P4 on both axes.
This is not a shortcut notation. You know why? Why you are writing this value? Tell me. If we know that all this diagonal distance between P1, P1 is 0, P2, P2, 0, P3. If we know it, so no need to calculate, right?
Okay.
And class, distance between P1, P2 is same as distance between P2, P1. Am I right?
Yes.
So that's why we eliminated. This is our standard way of calculating the distance, not this. You see here they are repeating. Look at here. P1, P2 2.828, P2, P1 2.828. So why to repeat? Why to repeat?
I
P1,
understand.
P1, P3 is same as P3, P1. You will not get the difference, right?
Yes,
Yes.
I can.
So
Yes,
that is
sir.
why this is optimized way to write.
Okay.
Tell me, any other question?
It's clear to me now.
Lucy, is it clear to you?
Yes, it is.
Dr. Rose?
Yes, yes, sir. It's
Okay,
clear.
Lonzo? Clear?
Yes, sir. Very clear, sir.
Callistus?
Answered before.
Clear, right?
Sir.
Very good. So, this is clear to you. One phase we are done. Let's talk about Minkowski distance. Let's talk about this distance, Minkowski distance. This is general form of the distance, right? Minkowski distance. This is pk minus qk modulus to the power r and then 1 by r. Look at, let me remove it so that you should write it fresh. I used to save it actually. So once it's saved, then it is the previous lecture which was written by me. Note down this class. This is formula for Minkowski distance. And point pkqk modulus to the power r and then 1 by r. Noted?
So what is R here and
I don't know. R is any parameter.
okay.
Noted, class?
Yes, noted.
Good. Now R is your any parameter. Look at here. If you are talking about Manhattan distance, right? So many distance, Hamming and Manhattan, you'll see R will be 1. If you make R equal to 1, it will be R equal to 1. So generally distance between 2 points, just like you calculated in 1 dimension, is the difference between 2 points, right? Class.
Yes.
Yes, sir.
What is distance between 2 and 4? They are in 1 dimension. Is it not 2?
It's true.
Yes.
So that is R is 1. Euclidean distance R will be 2. If you take R equal to 2, this is 2 1 by 2. So it's like 2 means
Yeah.
you just make their square and take the square root. Correct?
Yes. Yes, sir.
So R can vary depending on our situation. Like you see, note down the formula. Okay, look at here. If you talk about R equal to 1, we call it city block or sometime Manhattan or taxi cab L1 norm. So many name given to this, right? R equal to 1. Somebody will say city block, somebody will say Manhattan, taxi cab L1 norm, right? Or
Yes, sir.
somebody can also say Hamming distance. Hamming distance is also one of the name. It's just the number of bits that are different between two binary vectors. So Hamming distance is for binary vector. If they are different in 2 bit, how many places they are different? Right?
Yes, sir.
Good. R equal to 2, you did Euclidean distance already. So there is no problem where here. R is infinity. Look at here. This R can be infinity also. So we call it supremum distance. R is infinity means it is supremum distance or sometime L maximum or sometime L infinity norm, right? This is the distance. So this is the maximum difference between any component of the vector. For example, L infinity of 1, 0, 2 and this. Maximum difference between any two components. Look at here, 1, 6 is 5, 0, 0 is 0, 2, 3 is 1. Maximum distance between two is 5. Am I right?
Yes.
That is your supremum distance, infinity, or we call it maximum, or we call it any number, supreme, right? Clear?
Clear.
So can you just note down these points and calculate L1 norm, verify this, and verify this. Note down these points. 1 minute. Let me clean it. Yes. This is the left hand. Let me clean it again. Okay. You note down the left hand side and check the right hand side thing. Class. What is your objective? Just calculate and check whether this is L1 norm, L2 norm. L2 is Euclidean distance, L1 is that's like Manhattan, L infinity is supremum distance. Class, are you done?
Mm.
Hello? None so?
Yes, sir. I'm here, sir.
Are you done?
From what I've gotten, I'm taking it, sir.
Look at here. Yellow one distance between P1, P1, 0. P1, P2.
Yes,
What is yellow one distance?
the
2
first
and
one is
2, 4,
very clear.
right?
Exactly, yes.
That one is clear. Yeah.
What about this? It is Euclidean distance class. L2 means is Euclidean distance.
Yes,
L2
sir.
is, yeah, P1, P2. What is distance between P1, P2? Yeah? 0 minus 2 root 8, right?
It's
So
2.
root 8 is 2.828. Is it not clear?
Yes, sir.
It's 2, sir.
So this supremum distance between maximum. So this is P1, P2. P1, P1 is 0. It's not like you are going to count it. Diagonal is 0. Diagonal is 0. P1, P2, 2. P1, P3 is 3. 3 maximum, 2 is 1, 1. So this will be 3 maximum. P1, P4, 0, 5 is 5. 2 is 1 is 1. So it's like 5. 5 is maximum. Right, class?
I
Hello?
don't understand infinity. Can you just solve one? Let's see, please.
Infinity means like, distance in L infinity means you have to take point-wise maximum. So if somebody is saying distance between P1 and P4, so this point 0, 5, it is 5. 2, 0, 1 is 1. So what is maximum? Is it not 5? 5. So that's why 5 is written. Clear?
Okay, we are only taking the maximum.
Yeah, you see this now. You see here.
Okay.
You see maximum, supremum. You see 1, 6,
Okay.
5, 0, 0 is 0, 2, 3. So component wise maximum is 5, right?
Okay, understood now.
Complete this table.
American University of Nigeria.
Done, class? Hello? Are you done?
Almost, sir.
Yeah. Hmm.
I hope you are done, right? Hello, class.
Hello, sir. We are
Yes,
here.
are you done?
Yes, sir.
Any doubt?
No, no.
It's very simple, right?
Yes, sir.
Yeah,
Yes, sir.
so here, so we talked about three different distance measure, right? So one is like R is one, city block, Manhattan or taxi cab L1, or like Euclidean and supremum distance, right? Yeah. So, class, this Mahalanobis distance will cover after something like this require covariance and something calculation, but not now. I will cover it later on. Hmm? This Mahalanobis distance is not point of discussion now because this will require covariance matrix and some other discussion also. So we'll cover it later. Hmm? Clear?
Yes, sir.
Okay.
Yes, sir.
Yeah, especially when we talk about DB scan, some other clustering, then we'll cover it. Yeah. So common distance property, I'm not interested now. If you just understand distance between 2 points is greater than or equal to 0. Distance between PQ is same as distance between QP, right? And this is following the triangle inequality. Distance between PR is less than or equal to distance between PQ and QR, right? This plus Q. Clear? Clear, class? So distance between PR is less than or equal to distance between PQ plus distance between QR. Clear? This is always happening. This is always happening. This distance direct, if you are going with multiple, this is following triangle inequality. So distance between PQ is always less than or equal to PQ. PR is less than or equal to PQ plus QR. Clear? Is it clear? These 3 points of the distance. A class, is clear? Not clear?
So, not too clear, sir.
Okay. Okay, not clear. This is common property of a distance. You know, distance is always positive. So number 1 is not a problem, right? If you are given any 2 points, do you think that distance between them is negative?
No.
No.
That's why it is written greater than or equal to 0.
Yes, sir. Yes, sir. Yes, sir.
This is clear. Distance between 2 points is same as symmetric,
Yes.
like
Yes,
distance
sir.
between PQ is same as distance between QP, right?
Yes, sir. Symmetric. Yes.
And this is Euclidean. This is very popular triangle inequality. You see, if you are having point like see here, this is the point. So if somebody is saying that this is P and this is Q, this is R, right? So distance between PR, this guy, is always less than or equal to sum of their distances, right?
Yes.
This is
Yes.
always happening.
Pythagorean theorem.
Yeah, yes, you can say that this is Pythagoras
Yes.
theorem.
So go square.
That is
All
the
right.
origin actually. If you just talk about origin, it was originated from there, right?
All right. All
Okay,
right.
sir.
This distance is not like it originated from there. Euclidean distance, Pythagoras, all these things they are there. So it's not like something you are studying new. Everything is like old. Okay. So this we call it metric. Okay. So similarity between binary vector. Let's understand it. Yeah. Similarity between two binary vector will be calculated differently. Yes. So how to calculate similarity between two binary vector? M01, number 1, the number of attribute where P was 0 and Q was 1. Number, you need to calculate the number 1, 0. First one was 1, second one was 0. 0, 0, both are 0. 1, 1, both are 1. So this is the similarity. So this between binary vector, we are calculating two similarity. One is simple matching. We call it SM, simple matching coefficient. And other is Jaccard coefficient. Jaccard is very simple JC. So SMC means simple matching coefficient. If both are matching, 1 1 or 0 0 divide by overall. 0 1 1 0 1 1 1 0 0. Right, class?
Yes, sir.
Hello. Clear?
Yes, sir.
And Jaccard is 1 to 1 only. We are not including 0. 0 0 was excluded from numerator as well as denominator. That becomes Jaccard coefficient. Put down the formula, then I will do some example. Note down the formula.
Which of the formula?
Is it
Okay.
the last line, sir?
This one also, and this SMC, and this Jaccard.
Okay.
Hold on. Let's take note.
This is the special similarity between binary vector.
Okay. Balance mega mali ondo e da wara.
Hello, sir.
Noted?
So it means in this SMC, the
Yes.
matches for the division, the matches are also included as attributes.
Yes, yes, yes.
Okay.
Formula is very simple, simple matching coefficient matches divide by overall. But
Okay.
in Jacquard one, only one point divide, you just exclude the 0 point from the numerator as well as denominator. It was invented by Jacquard and simple matching. So this is not in our hand, right? Okay. So let me ask, if I'm talking about one vector, let's say x. 1 0 1 1 0 1, and let's say y 1 0 0 1 0 0. Can you calculate SMC? Yeah, calculate SMC. Calculate M01, calculate 1 0, and calculate 0 0, calculate 1 1.
There is no bold in number.
In SMC, for example, M11 is where P and Q is equal to 1, right?
Mm-hmm.
Okay, so
How many times they are 1 1? Tell me.
it's only 2.
So this M11 is 2, right?
I'll write 2 or I will signify with 1.
You will write 2. Number of times. Look at here. Number of matches. Number of attribute, right? Number. 0 0.
Okay.
0 0 is 2, right?
Yes, okay.
Divide by 0 1. 0 1, how much?
Okay, are we going to do separately?
1 2.
No. 0 1. 0 1 is 0, right?
0 1 is
0 means first is 0, second is 1. How many places?
0 when P is 0 and Q is 0.
0.
0, right. 1 0 1 0 1 0 1 0. Is it not 2?
2.
So I don't understand.
Oh God! Don't understand. What is here to understand? Tell me.
Yes, sir, it's getting clear because what I did is the M1, for example, in the formula SMC, what I'm doing is that
1 minute, 1 minute.
Mm.
I'm coming. Yeah. Tell me, where is the problem? 1 minute. Let me just clear the definition. This 0, 1, 2 vectors are given. Its meaning is the number of attribute where first vector is 0, second is 1, right? So if you are talking about this first as P, this is second. So if somebody is saying M11, what is M11 here? M11 here means first is 1 and second is also 1. So this is 1 time. This is 1 time. So is it not 2? Clear?
2, sir.
Clear now?
Yes, sir.
Yes.
And 0, 0 means first one 0, second 0. This and this. Is it 2? Clear, right?
Yes, yes, sir.
Divide by M01. First 0, second is 1. So nothing. Nobody is there. So it is 0.
0.
1, 0. First is 1, second is 0. This is 2 places. 2. 1, 1. Both 1. Both 1. It's 2. Very simple. Both 0, 2, right?
2.
Is it not 4 by 6?
2 by 3, sir.
That is SMC.
okay, understood.
You know, this is very basic for the binary number. And you know here Jacquard. Jacquard is so simple. Just calculate 1, 1, 2, divide by 4. So it will be 1.2, right? Jacquard. Jacquard, you know, you are just skipping this guy. This guy. So, you know, 0, 0. So 2 by 4. So answer is 1 by 2. Clear?
Clear.
Yes, sir.
So no matter how Jacquard is simple, we still have to deduce the M11, M01, M10, and M11. The rest,
Definitely.
the parameters there,
This is
we have
the
to deduce
formula.
it.
You have to apply the definition. You know, this
That's what
very, very simple for binary number, because you know in binary we don't want to be calculating the differences.
Okay.
Look at here. This is already being calculated. This is already being calculated. You can verify it from your side. Check it now. Check and check whether it is correct or not.
Okay, sir.
Let me erase it, this working. Because if working is there, you may not enjoy. Yes, check it now. This is solved answer. Check it. Is it okay? Check the solution. It is already solved question.
It's correct, sir.
It's correct, sir.
Very correct. Very correct. I'm happy at least you are following. You know, in binary number, you remember, it is not, you know, you are not going to calculate the differences timing distance. If you just calculate timing distance, it will be 3, right?
Yes, sir.
Yeah, because 3 places they are differing. So we are not interested into that. Clear, class?
Yes, sir.
Okay. So last similarity remain in this is cosine similarity. Cosine similarity. Cos. Cosine means cos. Especially it is very popular in the case of document, right? Especially when your document is being represented by number. So this cosine similarity is very, very popular. You know that cos theta, how to define the cos theta? So you know vector A dot B. How is defined, class? A dot B is mod A. Am I right? Mod B cos theta. Is it clear?
Mod B.
Yeah, mod A mod B cos theta, right?
Cos theta.
Yeah. So this
Okay.
means that, yeah, you know, you remember vector dot product mod A mod B into cos theta, right?
Yeah.
Yes, sir.
So that means cos between like two vector cos d1 and d2 is d1 dot d2 divide by mod of d1 mod of d2. Clear?
Yes.
And where d1 and d2 are dot product, and dot product, you know that it is component by component. If you somebody is saying d1 dot d2 component 3 dot 1 plus 2 dot 0 0 dot 0 plus 5 dot 0 up to and so on 2 dot 1 and then 0 dot 2, it is 5, right? Very simple. And
Yes.
norm of d1 is just like distance of d1. D1 is square. Norm of d1, how to calculate norm of d1? 3 square is 9, right? Plus 2 is square 4. You know the length of that. 5 is square 25 plus 2 is square 4. So this is the answer. So this will be 6.481. Clear?
Yes, sir.
Yeah, this is the norm of the norm means length of the particular vector, right? Yeah. Similarly, length of D2 is norm of D2 is how much is this, class? Norm is 1 is square 1 plus 1 plus 4
Plus
is
4.
like it's very, very simple. It is square root of 6, which is 2.245. Clear?
Yes, sir.
So distance is very, very simple, class. You know, this just 6.481. So d1 dot d2 is 5. Divide by norm of d1 is 6.48 and into 2.24. This is cosine
2.24.
similarity. This is cosine similarity. Whatever answer is coming, distance will be 1 minus cosine similarity. Distance is, you know, this is cosine similarity. Calculate cosine similarity. Cosine similarity is coming to be this, and so distance will be 1 minus 0.3150. Yeah, this is distance. Clear? Clear, class?
So, but the distance equal to 1 minus cos.
1
open
minus
bracket.
cosine similarity, yeah.
Yes, yes. Where is the formula coming from? And apart from that, sir, from the information I'm seeing here, more than D1, is it more than the one that has more than D1 and more than D2? I can see when you come down to calculate, I'm seeing 3 asterisk 3 plus 2 asterisk 2 plus this. But the
This
formula
is length of distance 1, length of vector. D1, you know, norm D1 means length of D1.
okay, length of D1.
You know how to calculate length of a vector, right? You know,
Yes.
length of any vector is like square this, add every square and add them together to and get the square root, right?
Okay. Okay.
And this distance, you know, is 1 minus cosine similarity. We are not going on derivation of the formula.
Okay, sir.
Just like you see Jaccard coefficient and simple matching coefficient. We are just interested in knowing the formula, not their derivation.
Okay, sir.
So cosine similarity, first calculate cosine for distance, cosine between two document vector, then distance will be 1 minus cosine value, right? And you know that cosine value will always be like between 0 to 1, clear?
Between 0 and 1.
Yes, sir.
Noted, class?
Yes, sir.
So that's all
Yes,
about
sir.
this similarity and distances. Remain Mahalanobis distance. I told you that we will cover after some certain time. This Mahalanobis is very, very important. But this distance is using covariance matrix. So I'm yet to introduce covariance and correlation and something. So once I introduce covariance matrix, then we'll cover this Mahalanobis distance.
Okay, sir.
Yeah,
Okay,
you may
sir.
not understand now actually. So this is all about the distance measure and similarity. So now we are ready to understand the clustering from next class.
Okay, sir.
Any question till now? Class, any question till now?